Welcome to section 2.4. Today we're going to be talking about postulates and diagrams. So our first set of vocabulary today is a line perpendicular to a plane. So a line is perpendicular to a plane if and only if it is perpendicular on every line from that plane. So I'm just going to add to the beginning of this vocab word just to make this a little shorter definition. So I'm just going to say a line perpendicular to a plane has to be perpendicular on every line from that plane. So has to be perpendicular from every line on that plane. A few new postulates for this section. So through any 2 points, there exists exactly one line. A line contains at least 2 points. If 2 lines intersect, then their intersection is exactly 1 point. Through any 3 non-collinear points, there exists exactly one plane. So remember, non-collinear means they're not on the same line. And then a plane contains at least 3 non-collinear points. If 2 points lie on a line, if 2 points lie in a plane, then the line containing them lies in the plane. If 2 planes intersect, their intersection is a line. So then we're going to look at some postulates and we're going to determine which of these postulates would be used in the illustration shown. So we see in that first illustration, we have 3 points that are non-collinear and they're showing that they're on a plane. So that would have to be postulate number 8, because through any 3 non-collinear points, there exists exactly one plane. So that's postulate 8. Okay, part A on this next section. So if it shows 2 lines intersecting and then it shows they intersect in 1 point, so that would have to be postulate 7. Then it shows 2 planes intersecting and it looks like they intersect in a line. So that's postulate number 11. And then on example 2, identify postulates from a diagram. Use the diagram to write examples of postulates 9 and 11. So postulate 9 is a plane contains at least 3 non-collinear points. So we want to look for points that are on one of the planes that are not linear. So I'm going to look at plane Q, which is the graded one. Sorry, the gray one. Plane Q. And 3 non-collinear points on that would be V. So points V, Y, and W. And then postulate 11 is if 2 planes intersect, they intersect in a line. So we want to look at the intersection of plane P and plane Q, and they intersect on line B. So we're going to say plane Q and plane P intersect at line B. Okay, so that's that section. Then if we move over to the other side, so it says use the diagram in example 2 to complete the following exercises. Which postulate allows you to say the intersection of line A and line B is a point? So we're looking at line A and line B. They intersect at point Y. And the postulate that tells you two lines intersect in a point is postulate 7. I'm just going to put P7. Then they want us to write examples for postulate 5 and 6. So postulate 5 is through any 2 points, there's exactly one line. So I just need to find 2 points on here that form a line. So I could say points X and Y form line A. So points X and Y. Okay, then looking for postulate 6. So postulate 6 is that a line contains at least 2 points. So we want to look for a line that has 2 points. I'll try to find a different one this time. So X and Y, yeah, it looks like that's the only ones that are shown in that example. So I'm just going to say, since we're doing postulate 6, so line A contains points X and Y. So just the opposite. Okay, so just a quick summary here. So when you're interpreting a diagram, you can only assume information about size or measure if it is marked. So in this diagram here, you can assume that all these points are coplanar because they're all in plane P. Angle AHB and BDH are a linear pair. So you can see those two are adjacent and they form a line. AHF and BHD are vertical. And then AHJ and D are collinear. Lines AD and line BF intersect at H. So you can't assume that G, F, and E are collinear. So these points here. So even though they may look like they're collinear, because it's not marked as collinear, you can't assume that. B, F, and CE intersect. So BF and CE, they look like they're probably parallel, but we don't really know, so we can't assume anything. So we also can't assume they do not intersect. Angle BHA, so that's this angle here, is congruent to angle CJA, sorry. CJA, so here. So we don't know enough information to assume that those two are. If we knew those two lines, the BF and the CE, were parallel, we could make that assumption. But we do not know that they're parallel. And then we also cannot assume that AD is perpendicular to BF. So AD is this line going across here. We can't assume that those are perpendicular and that there'd be a 90-degree angle because it's not marked. So basically, moral of the story, you cannot assume anything that's not marked. Okay, so next they're going to ask us to sketch a diagram. So it says sketch a diagram showing RS perpendicular to TV, intersecting at point X. It is also given that RX is congruent to XS. Okay, so we've got a segment RS. We know it's perpendicular to, I believe that's a line. It's hard to tell if there's arrows on the end of that. I'm going to say there are arrows on the end here. It's just really hard to tell. And TV. They're perpendicular, so they form a right angle. And it also says that Rx is congruent to XS. And they intersect at point X. That's important. So this is congruent to this. So there's our diagram we would draw to show that information. Okay, so continuing on. Which of the following statements cannot be assumed from the diagram? So E, D, and C are collinear. So let's find E, D, and C. So it looks like those are all on the same line. So I'm going to say that's okay. So we could assume, so we're not going to circle that. Then it says the intersection of BD and EC is D. And EC is D. Yep, if you look at those lines, they do intersect at D. BD is perpendicular to EC, so that is something we can't assume. There's no 90 degrees marked. EC is perpendicular to plane G. So EC is perpendicular to plane G, which is the white one. It looks like it, but there's no 90 degrees marked, so we cannot assume those. Just note in the answer key, it has it reversed, but this is the correct answer because they're asking for which ones can we not assume. Okay, so example 5, I'm going to let you try that on your own, and you can check your answers in the key. It's kind of a challenge problem, but I will give you the answer key on Google Classroom. So give that a shot, see if you can draw that out. And that is it for section 2.4. See you next time.